Hello and welcome to this video about using Docker and Docker Compose to run services for local development. It's pretty common for most non-trivial applications to interact with external services. For example, databases like Postgres, caches like Redis, or queues like MQRabbit. And you'll often want to have the full application running locally during development and testing. So you could, of course, install all of the required software on your machine. However, this has a number of problems. For instance, it's very slow, as in actually installing and configuring these pieces of software can be slow and difficult. I'm sure we've all started a new role and had to set up our machine for development, following some huge guide in Confluence or README, and this makes your machine become an extremely precious thing because you know that if anything happens to your machine, you'll have to go through the nightmare of setting everything up again. Uh, the installing software on your machine also tends to be very inconsistent. You often end up with slightly different setups across the team, and the typical "it runs on my machine" issues usually crop up. Luckily, Docker and Docker Compose can make setting up your local development environment much simpler and much more consistent across the team. To give a full worked example of using Docker for local development, I've created a Flask app in Python that keeps track of the animals in a zoo or some aristocrat's menagerie, something like that. The Flask framework that we're using here is just a simple framework for creating web apps in Python. So you can see I've got a function here called getAnimals, and that's been associated with just the / endpoint. So when someone makes a HTTP request to / it calls this method. And all this method does is connect to a database running on localhost with particular credentials, and then runs this select species and counts from the animal table, and then prints out the results as a JSON object essentially. So we can start this application running by opening up the command line and then just typing flask run. And what that does is start a server running, and it's listening on port 5000. So we can open up another terminal window and just curl that endpoint. So what we should see is it will give us a 500 or something like that because this database isn't running. So we get like a 500 here, and here we're saying it cannot connect to localhost. So let's start Postgres running in a Docker container. And to do that, we use the docker run command. So if we'll open up another terminal and start with just simply docker run. And this takes a couple of parameters. The first being the image itself, which is just called Postgres, and that's available on Docker host, Docker Hub. And then we can provide a name just to give it a nice name, so ZooDB. And we need to expose the ports. So Postgres runs on 5432 by default, and we'll just expose 5432. So from the container port is the second one, and the host port is the first number here. So essentially, localhost 5432 will pipe to inside the container 5432. Next, we need a couple of environment variables, and we pass those using the -e argument like that. So we're just providing in the default password for Postgres, which we'll just leave as Postgres, and the name of the database that it's going to create. So we'll call it ZooDB. And the final thing we want to add is -d, which is just for detach, and it just means that it will start in a background process rather than in this main process. So we can see the Docker container running using the docker ps command, where ps is just short for processes. So we see our zoodb running, and we see the ports that are exposed. So although we have the database itself running, if we make the same request to our endpoint, we'll still get 500, but possibly it will say something different. And what it's saying here is the animal table doesn't exist. So what we need to do is essentially shell into our Postgres container and create a table, and ideally insert some animals into the table. And the way we do that is using the docker exec command, and that just allows us to run essentially any old command. For example, if we wanted to know the version of Postgres that zoodb was running, we can do docker exec the container name, which is zoodb, and then just simply pass in the command that we'd like it to run, in this case just postgres-v, and that will tell us that we're running Postgres 13.1. So instead of running Postgres, we could instead open a shell with just sh, and we'd have to use some other parameters, for example, I, which means interactive, and T, which essentially means open a terminal. And if we run that, we are now essentially inside the Docker container. So we can again do our Postgres-v to print out the version. And we can do much more than that. For example, we can use psql, which is just a command line tool for running SQL, to log into our database or our instance of Postgres, and then connect to the zoodb database. And now we can run some SQL. So we'll start by creating our animal table with just a create table statement like that. And we'll insert an animal into our database as well, into our table. And then we just exit out of this. So now that we have everything properly set up, if we go back to our command where we're doing our curl and then make the request now, we do actually get the data directly from the table. So the table itself has all been set up. In a second, we'll use Docker Compose to simplify all of those steps into just essentially some YAML and some SQL. But before that, we'll just mention a few handy Docker commands. So right now we have our Docker Postgres instance running, but we'll at some point probably want to stop it, and that's luckily as simple as just doing stop and then the name of our container, and that will stop it. If we just do docker ps again, we'll see it's not running. And if you need to restart it, you can just use docker start, and then that will restart it. And if you want to remove the container altogether, you first have to stop it again with stop, and then the name of the container, and then finally you can remove it altogether. And that means that you'll now be able to do another Docker run and reuse the zoodb name. So working with Docker like this is great. It sort of gets the job done. However, starting multiple services can be a bit of a pain, and there's also that manual step of creating the tables and other sort of configuration. And this is where Docker Compose comes in, and it allows us to start a set of services defined in a single YAML file. a YAML file just called docker-compose, like this. And in this, we just write some XML, some YAML that describes the services that we want to start up. So this is the equivalent of what we did earlier with our environment variables of the password and database and the ports to expose, and obviously the image itself. And here we've just got DB as the service name. So with just this file, it would start an uninitialized Postgres running, essentially the same as the Docker run before. But really, we can do better than this by mounting an init script that Postgres will pick up and run to create the tables and insert the data, essentially simplifying the whole process of getting this database ready to be used by the app. So to do that, we'll create an init.sql file and just pop sort of similar statements to what we were running manually. So I'll create a table here and we just insert some additional animals. And then we need to go back to our Docker Compose file and mount this script. So what this is doing here is saying mount our init script, which is just here, as though it's this file in the container itself. And this is what Postgres on startup looks for, and runs any scripts in that file. So now that we've created our Docker Compose YAML, we should be able to just run the Docker Compose up command along with D to get Docker Compose to create containers as described in our Docker Compose YAML. So the D here is exactly the same as the Docker run, it just detaches it from the main process. So you can see this is creating a container for this DB service. And we should be able to do Docker Compose PS, like with Docker PS, to view the services that are running. So it looks like our Postgres is spun up fine. So hopefully we should be able to do another call to our application that we've got running, and it will hopefully print out all of the animals that we created in our table here. And it does. So you can see we've simplified the steps that we had before, where we had to execute into the container and open a shell, to just two files, our YAML file and our initialization SQL file. Along with the up and ps commands, Docker Compose offers a few other things to see what the containers are doing. For example, we can do Docker Compose logs, and that will just give us the logs for all of the applications. So we can see here that it's logged that it's created the database and inserted those 5 animals here. And we can also do Docker down, which is essentially the opposite of Docker up, and it will stop all of the containers and then remove them. And we have these other functions such as Docker Compose start and Docker Compose stop. And what they do is Docker Compose start is similar to Docker Compose up, but it won't actually create the containers. So if we were to just do it right now, for example, it will actually crash because the containers don't exist, or error because the containers don't exist. So the sort of correct pattern, if you like, is Docker Compose up, which creates the containers, and then we do docker compose stop, which stops the containers but doesn't remove them. And then now with docker compose start, we'll be in a situation where it can just start the containers running. To round everything off, let's add another service to our docker compose file that will interact with this DB service. And what that other service is going to be pgAdmin, which is just a tool for monitoring and interacting with Postgres instances. And luckily, it runs in a Docker container, the same as Postgres itself, and we can just add it to this file, like so. So the image is just pgAdmin4, and we provide some environment variables for the default login credentials. So we could just do docker compose up right now. However, this instance of pgAdmin won't be pre-populated with the Postgres connection that we've got here. So let's add some configuration to pgAdmin to essentially pre-populate the pgAdmin sidebar with this Postgres instance. And to do that, it's kind of similar to this int SQL, but instead it's this service.json file, and we mount that in a particular location for Postgres admin to pick up. So it's just called service.json, and we'll give it a bit of JSON describing the ZooDB. So one thing to note here is it's not localhost, it's DB, and the reason it's DB is because Docker Compose essentially sets up like a mini network for the different services to connect to, and it names them based on the service name. So if you ever want to refer to another service running in your Docker Compose script, you'll have to pass in its service name up here. But everything else is pretty normal, like the Postgres ports and the usernames and everything. So now we can mount this file in our Docker Compose file for Postgres admin to pick up. So exactly the same as our init SQL, but mounting it to a different location where pgAdmin will be looking. So now we can run our docker compose up command, and we should see both of the containers starting up. And if we just give it a few seconds to load, we can try signing into Postgres admin. Starts up on port 5050, and we should be able to log in with our admin at admin.com and pass in the password. And we see here it starts up with our ZooDB already set up, and we just simply need to provide the password, which is Postgres. And now you can interact with our DB in a sort of convenient, nice GUI. If you work in a team that's already familiar with Docker and Docker Compose and are working on applications that interact with dependencies like databases and queues, I can almost guarantee that your colleagues will appreciate you taking the time to make working with, a particular project much easier. So essentially introducing Docker and Docker Compose into the workflow. Hopefully you found this introduction to simplifying your local development environment with Docker useful. As always, any suggestions or questions are welcome in the comments. Thanks for watching.